Welcome to section 8.4, and please note in 8.4 we're only covering objective 4. So that's just word problems with quadratic equations. Alright, so example 1. A ball is projected upward from the ground. Basically that means it was thrown upwards or maybe tossed upwards. Its distance in feet from the ground at t seconds is given by the function s of t equals negative 6t squared plus 64t. Basically this is saying if you're on the ground and a ball gets tossed into the air, right, we have a ball flying into the air, its path, when it goes up and then comes down, right, because what goes up must come down, can be described by this quadratic equation. And once again, one thing to note, quadratic equations, when they graph, they come out as something like a parabola, which is the path when things are thrown in the air, right? If you throw something into the air, or even if, you go to a water fountain and you just hit the button for the water fountain, it'll come up in an arc, which is basically like a parabola, something quadratic. A bit more simplified, but that's basic the thought. And what this is saying is, if you pick a second, t, let's say if you said t equals some second, you can plug it into this equation and you'll figure out where your ball is at that time. Kind of neat. So what is it asking? It says at 2 seconds, how far from the ground is the ball? So we're told 2 seconds, and we want to know how far. So we're told that t is 2, and we want s of t, because that is the distance in feet from the ground. So let's go ahead and find that. S of 2 equals negative 16, and once again we're inputting 2 for t. Inputting 2. And we get negative 16 times 4 plus 64 times 2. 64 times 2 is going to be 128. And then, let's see, what is 16 times 4? 16 times 4 is going to be 24, 64. So we have negative 64 plus 28, or 128. Let's go ahead and do that subtraction. If you're allowed to use a calculator, you can. If you're supposed to be doing it by hand, let's do this by hand. 8 minus 4 is going to be 4. Can't use 2 minus 6, so borrow from the 0, or borrow from the 1, which becomes a 0. And then that's going to be 6, so 64. So S of 2 is 64. What do you know? What does this mean? Once again, this is a word problem, so we need to describe what this means. Well, this means at 2 seconds, what do we know? Remember, S of t describes the distance in feet from the ground. So at 2 seconds, the ball is 64 feet from the ground. That's pretty high for 2 seconds. That's quite a bit of power there to get a ball up that fast. Okay, so let's take a look at part B. At what times will the ball be 32 feet from the ground? Round to the nearest tenth as needed. So now what we want to know is what time. So we don't know the time. So we want t, which is the time, when what? When s of t equals 32, because this time we're given the distance from the ground. So we're still going to use the equation we had above. S of t equals negative 16t squared plus 64t, but this time we're taking away 32. Sorry, we're taking away s of t and replacing it with 32. Alright, let's see. So this is quadratic. How do I know that? Once again, it's quadratic because I have the t squared. Can I simplify this? Because these are some big numbers. I have a feeling that these all might be divisible by... I know they're all divisible by 4. The question is, are they all divisible by 16? Let's see, 32 is 4 times 8. So yes, I think these are all divisible by 16. But let's go ahead and divide it by what I know. Dividing everything by 4. 32 divided by 4 is going to be 8 equals, and that's negative 4t squared. And 64 divided by 4, let's check that. 4 can go to that once. 24, that's going to be 6, so 16. And all of these numbers, 8, 4, and 16, these can all still be divisible by 4. So let's go ahead and divide by 4 again. Once again, simplify if you can. Making the number smaller makes your life way easier. So it'll be negative t squared plus 8, plus 4t. And this is quadratic, so let's go ahead and do the zero factor property if we can. If not, we might need to do the quadratic formula. So minus 2 from both sides. So it equals negative t squared plus 4t minus 2. I don't like the negative in front of my t squared, so let's go ahead and divide everything by negative 1 to get rid of that. And I'm left with 0 equals t squared minus 4t plus 2. I don't believe there's a way to factor this. I don't know factors of 2 that can give me a 4, since that only has a factor of 1. So because I can't factor it, I can either do completing the square, or I can do the quadratic formula. So let's go ahead and do the quadratic formula. So I know that t is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. I just need to figure out what a, b, and c are. So my a value is going to be by the t squared, which is just a 1. My b value is going to be what's by t, so that'll be negative 4. And my c value is just a number, so that's 2. So let's go ahead and plug those in. So negative b, so that's negative 4. Let me color code these. So negative 4 plus or minus the square root of b squared, so negative 4 squared, minus 4ac all over 2a. Okay, so t is going to equal 4 plus or minus the square root of 4 squared is going to be 16 minus 4 times 2 is going to be 8. And times 1, that'll still be 8. We'll go ahead and fix that radical, it's a little too big. And now it's all going to be divided by just 2. So t is going to equal 4 plus or minus the square root of 8 divided by 2. Can I simplify this? Well, I know I can simplify that 8, because remember in 8 there's 4 and 2. So it's going to be 4 plus or minus the square root of 4 times the square root of 2 all over 2. So it's going to be 4 plus or minus 2 root 2 over 2, and I can factor out that 2. So that'll be t equals 2 times 2 plus or minus root 2 over 2. Canceling those 2's, once again, you can only do that once you've factored it. Then we have t equals 2 plus or minus root 2. Okay, so, what was the question? At what time will the ball be 32 feet from the ground? Round to the nearest tenth is needed. Well, let's see. Do both of these answers make sense? We have two possibilities. T is 2 plus root 2, or t is 2 minus root 2. Let's approximate this, because it's a word problem. If somebody said to you, how much money do I owe you? And they said, well, you owe me 2 plus root $2. Does that make sense? It doesn't. So usually they approximate or round. Not necessarily in money, but in other things. So to approximate this, what is root 2 near? Well, root 1 is 1. What's the next perfect root we know? We don't know root 2, we don't know root 3, but we do know root 4, and root 4 is 2. So I know that root 2 is in between 1 and 2. So let's go ahead and pick roughly 0.5. So I'm going to go ahead and write down that I'm approximating. Definitely do that if you're working with math. T is approximately 2 plus 1.5, or t is approximately 2 minus 1.5, which means that t is approximately 3.5, or approximately 0.5. Does this make sense for a word problem? Do both of these work? Well, yeah, it makes sense to have 0.5 seconds, and it makes sense to have 0.35 seconds. Now, once again, note, if you're allowed to use a calculator in your class for Math 103, you'd use your calculator to approximate this answer. But if you don't have the calculator to use, like for Math 82, that is when you would do the approximate for your answer. Once again, this is Math 82, this is Math 103, use your calculator. Okay, so then our answer would be, what time will the ball be 32 feet from the ground? The ball will be 32 feet from the ground. I'm running out of space. From the ground at 3.5 seconds and 0.5 seconds. Once again, use your units, that's talking about seconds, and use context. Don't just say at 3.5 seconds and 0.5 seconds. You need to say what? The ball is going to be doing what? It's going to be 32 feet from the ground at what? 3.5 seconds and 0.5 seconds. Make sure to include the context and the units. Once again, it is a complete sentence. We are in college and we are planning to go out into the real world. So definitely make sure the sentences make sense. Alright, let's go ahead and go to the last problem, I believe. Yeah. Last problem for this section. Kealoha is building a small garden in the shape of a right triangle in the corner of her backyard. One leg of the garden is 4 feet longer than the other, and the hypotenuse is 10 feet in length. What are the lengths of each of the sides of her garden? Interesting. Let's go ahead and draw a visual here. We're talking about what? A garden in the shape of a right triangle. Okay, so it's a right triangle, which means there's a right angle there. What else do I know? One leg is 4 feet more than the other. So we don't know one of the legs. I'm going to go ahead and say x because I really don't know what it is. So it's my variable. And then what else do we know? One is 4 feet longer than that. So x plus 4 would be 4 feet longer. And, then we know the hypotenuse is 10 feet in length. So that's just 10. And now we need to figure out what x is. How do I do that? Well, hopefully something's coming to mind. Whenever you see a right triangle, a certain equation, a certain theorem should always come to mind. And that is the Pythagorean Theorem. That is right, the Pythagorean Theorem, as one of my math teachers used to say. So, that theorem is, if you have a right triangle, you take the two sides, the short sides, you square them, and they should end up equaling the long side squared. Okay, once again, the long side, C, is always your hypotenuse. The other sides, it doesn't exactly matter which one you put in. So let's go ahead and do that. So, taking my two sides, x plus 4, and then the x, and setting it equal to the hypotenuse squared, so 10. What do I get? I get x plus 4 squared plus x squared equals 100. Now be careful, once again, are we allowed to just distribute in the 2? The answer is no, please do not do that. That's a binomial being squared. What does that mean? That means we're going to write x plus 4 times x plus 4. Once again, we do not do that distributing in. I'm scribbling that out because hopefully that'll mean you'll never ever try to do that. I want you to get the right answer. Okay, so let's go ahead and do FOIL. So we get x squared plus 4x plus 16, and then bring down that plus x squared equals 100. Combining like terms, so we have 2x squareds. It's this one, and then our 2 x's, and then the 16 doesn't have a like term. Plus 8x plus 16 equals 100. Now this is a quadratic equation. How do I know that? We have the x squared. So let's go ahead and use the zero factor property. But before I do that, these numbers are all even, which means I can divide them all by 2. So let's go ahead and simplify. Once again, if you can simplify, simplify. So that's going to be x squared. That cancels, there's a 4 left. That cancels, it's just 8. And that's going to be 50. Okay, so now let's do the zero factor property. Subtract 50 over from both sides. That'll be x squared plus 4x minus, 42 equals 0. And now we want to see if this factors. Since these are kind of bigger terms, We could try and see if we can factor it. So let's see. So we have 42. That is 2 times 21. And 21 is 3 times 7. So let's see. Factors of 42 are going to be 1 and 42. 2 times 21. I could match those up and I could get 6 times 7. Or I could match 2 and 7 up, and that's 14 times 3. Or let's see, I could match up. That's basically it. Those are the ones I have. And I don't see how I could subtract any of these and end up with 4. So it's not going to factor. So I have two options. I can do the quadratic formula, or I can do completing the square. And now, since I already did quadratic formula earlier, let's go ahead and do completing the square. I want to practice both of our methods. So for completing the square, we're going to go ahead and move that 42 back to the other side. And now we need to find the perfect number that'll make my binomial at the moment into a perfect trinomial. We want to find this perfect number. How do we find that perfect number that we're going to add in? Well, we'll take the b value, divide it by 2, and then square it. So dividing it by 2 is going to give me 2, and then squaring that is going to give me 4. So my perfect magical number is 4. We'll add that in, and that will create the perfect trinomial. But I have to add it to the other side as well, because once again, I need to balance my equation. So add 4 to both sides. Why do we care about 4? Because it makes this trinomial beautifully factorable, which is what we were struggling with before. It makes this factorable into the two perfect binomials, x plus 2 times x plus 2 equals, and I'll add those together, and I get 46. So now I can rewrite these two as x plus 2 squared equals 46, and now we can solve. So square rooting both sides. Once again, remember, what do we need to remember? The plus or minus. Please do not leave that out. Don't want to be taking away points for that. So we have x plus 2 equals plus or minus root 46. Subtract 2 from both sides. And we get x is negative 2 plus or minus root 46. Alright, so once again, these are not going to end up being a perfect answer because 46 is not a perfect square root number. However, let's see, 46... Now, 46 divided by 2, that's going to be 23, and 23 is prime. Okay, so if you don't have calculator use, we'll go ahead and approximate it. If you do have calculator use, plugging that in, that is going to be about, let me go ahead and just write this down so you can know. So if you have calculator use, which is Math 103, if you have calculator use, you get x is approximately 4.78, or plugging that in, you get x is approximately negative 8.78. Okay, let me leave that at that, and let's find the answers if you had to do it by hand. Okay, once again by hand, we need to do approximations. This is for Math 82. Okay, so let's do this on the side. Root 46, what is that in between? What are two perfect square roots you can think of? Well, I know that root 25 is going to be 5, and then root 36 is 6, root 49 is 7, so 46 is in between 6 and 7. So let's go ahead and say it's approximately 6.5. That's a super approximate, but we're just going to use that for approximating. So that means x is going to be approximately equal to negative 2 plus 6.5, or x is going to be approximately equal to negative 2 minus 6.5. So x is approximately equal to, let's see, so 4.5, or x is approximately equal to 6, 7, 8, negative 8.5. And if you'll notice, that is actually not super close, but it's pretty close to the calculator approximations. Okay, so once again, Math 103, you have calculator use. Math 82, you do not. Okay, so do both of these answers make sense in the context of our problem? What are we looking for? We're looking for the length of the side of a garden. And we have two answers. We have the possibility of the positive answer, or the negative. And it does not make sense to have a negative length for your garden. So that does not make sense. So we would say extraneous and give a reason. Length of garden. Lengths cannot be negative. Or something like that. Just a small, short reasoning. And then we'll give our answer. So the lengths of the gardens, was that the question actually? The question was, what are the lengths of each of the sides? Yeah. Okay, so the lengths are, actually let me leave space for us finding the other one. So the lengths are going to be and I'll go ahead and just use the Math 82 answers. 4.5, 4.5 what? Feet. 4.5 feet. Sorry for all the roosters in the background of my recording. 4.5 feet by what? We need to find the other length. X plus 4. So we know that this side is going to equal 4 plus 4.5. It's approximately 8.5. 4.5 feet by 8.5 feet. And we are done. Alright, so once again, what happened here? We ended up with a quadratic equation which we couldn't factor. So our plan was either quadratic or completing the square, and we chose to complete the square, which is where we had to find that perfect trinomial number, the perfect number to add in to make my number easily factorable into identical values that we could then write as a square. In the previous problem, we had just decided to use the quadratic formula. So 2 ways to go about it if your trinomial does not factor. Alright, that is it for this section. If you have any other questions, please send me an email or pop by my office hour. Alrighty, that is it.